Whenever you're trying to learn something and learn it in a way that's kind of, memorization, rote memorization as we call it, it can be helpful to look for patterns, similarities, differences, things that will allow you to differentiate one object or one concept from another. And the same can be applied to the idea of polyatomic ions. Lots of different polyatomic ions. There are some similarities, there are some distinctions. There are some that are very, very similar to one another, and so the challenge can sometimes be being able to differentiate. How do I tell sulfate from sulfite? How do I tell the difference between carbonate and bicarbonate? And so if you can find ways to have formulas stick out in your mind, be memorable, or patterns that you can apply so you can look at the way the formula is written and apply that pattern, that can help you with both the names and also the formulas. So the first set of polyatomic ions I'm going to have you looking at, and that's the ones that are labeled with the number 1, you want to look at both the formulas and also the names. And you want to look for similarities. And one of the first things that you'll probably notice in the formulas is that virtually all of the formulas, not just in set 1, but in all of the sets, contain oxygen. When you look at the formulas that contain the oxygens, there is one of two places where the oxygen occurs. It's either at the end of the formula, like we see with nitrate and sulfate and phosphate, or it's at the beginning of the formula, like with peroxide and hydroxide. Now, when you look at the names for these, so if we consider these polyatomic ion formulas in these two categories, and then we flip the cards over and we look at their names, we see that there's a similarity in how the naming of those particular ions goes. For instance, the two that we have that have oxygen at the very beginning, OH minus and O2 with a -2 charge, are named respectively hydroxide and peroxide. And both of those names have the common ending oxide. So one of the things we can do is when we look at a formula or a grouping of letters and we say, you know what, I recognize that those go together, and that's a polyatomic ion, we see that it starts with an O, so we know that's going to clue us in to remembering that those ion names that had oxide in them are going to be the ones that we're going to choose from. The other formulas that had oxygen at the end of the formula, if you look at this first set, only the first set, you'll notice that the common ending is ATE. And so anytime you see a polyatomic ion name, or the name, somewhere in the compound where you see 8, that's cluing you in that, hey, there's a polyatomic ion involved. Secondly, that it's going to have oxygen in it, and namely that oxygen is going to be at the end of that polyatomic ion formula. Another clue, in this first set, whenever you look at these ATE ions, and quick side note, I mentioned before sulfate and sulfite, the difference there simply being the ending. What that is going to give us a clue as to is to the number or the relative number of oxygens that are present. And so in this first group where we're only dealing with ATEs, your choices for the number of oxygens, there's two choices. It's either going to have 3 oxygens or 4 oxygens. Okay, so for instance, if we have phosphate, all right, you see phosphate has 4 oxygens, whereas if we had something like nitrate, right, nitrate has only 3 oxygens. So as you're embarking on this first set of element symbols, realize that, okay, if I see a name and it's got 8 in it, I know it's going to have oxygen at the end of the formula. All right. As for the other element, it's pretty much in the name itself. Phosphate, nitrate, you can glean that other non-oxygen element from the name of the ion itself. As far as how many oxygens there are, again, this first set, your choices are 2. You've got 3 oxygens or you have 4 oxygens. So that can begin to help streamline the process of learning this initial set. The other thing with the ATE ions is they're kind of like our baseline form. So if you can really commit those to memory, then when we start to change endings, like to ITE, when we start adding in prefixes, hypo and per, then it will just become applying a rule to how does that change that baseline form. So just like learning your element symbols, making sure you know those like the back of your hand, these ATE form polyatomic ions especially are going to be really important to make sure you've got a good handle on those, and that's why they're in this first set. So there are other things that we can look at for the ones that are labeled in the second set and the third set, and we'll take a look at those coming up. Stay tuned.